Good morning, Veritas. Today is Friday, June 12th, 2020. It's our second to last day of school for the kids, so this is your second to last assignment of the year, so congratulations. You should have already completed these three problems here. Only two of them are here and one's on the back. These should already be completed, so if you have not, please pause this and work on these three problems independently to see if you can do them by yourself, and then watch this video carefully and we'll go over the answers now. Okay, so number one says find the quotient of 5,896 and 15. Then answer these questions. So first we're going to find the quotient, then we're going to answer these. What's the quotient written as a mixed number? What's the quotient written as a remainder? And with the star here, this is a hard one. What's the quotient written as a decimal? We've only done this 2 times and it's pretty complicated. So I know you guys can do it, but we're going to practice that again today. That's why there's a star here, is because C's pretty hard. Okay, so let's get started with this one. I'll read it again. Find the quotient of 5,896 and 15, then answer these questions. So first we're going to find the quotient, which is the answer to a division problem. So we are dividing 5,896 divided by 15, then we're going to answer the questions. Okay, so what I drew here out was 15, my coffee's ready, 15 circles here. We're going to make 15 equal groups. We're dividing 5,896 into 15 equal groups. We want to see how many will go into each equal group. Okay, so let's start with the thousands. We have 5 thousands, so we can't put 1,000 into each of these groups because we only have 5. Then the rest of these groups wouldn't have an equal amount. So we can't put any thousands into those groups, none. So we're going to then include the thousands with these hundreds. So since every place value as you move to the left is 10 times bigger than the one before it, this is 10 times as many hundreds. So that's, instead of being in the hundreds place, it's 10 times that. So that's actually 50 hundreds. So now we're going to look at this whole thing as 50 hundreds plus these 800s, and we're going to split those 58 hundreds into these 15 groups. Okay? And we could put 300 into each of those groups, because 3 times 15 is 45. 4 times 15 would be 60, and we only have 58 hundreds. We don't have 60 hundreds, so we got to use 3 here. So 3 times 15 is 45, then we subtract, we have 13 left. That's a big remainder there, but as long as it's less than our divisor, that means that we couldn't put it in one more time because it's less than 15. So if this was 15 or more, that would mean that we could have put one more in here. But since it's less than our divisor, we're good to keep going. So we put 300 into each group, then we have 1300s left. So we're going to mix those in with the tens. So now we have 139 tens. So if we had 139 tens, how many can we put into each of these groups? Okay, so you might have to kind of guess with this. 15, 30. So now I'm going to 60, 90. So let's see, 90. So we could guess maybe it's going to be around 7 or 8. Maybe we'll try 15 times 8 and see how much that is. That's 120, yep. And if we added 15 more to that, it would be 135. So we could do 9, okay? Because 8 was 120, so then plus 15 more would be times 9. What's 135? So we can put it in 9 times. So 9 tens can go in there, which are 90, can go into each of these groups. Okay, so 9 times 15. I'm just going to check that again one more time. Oops. 9 times 5 is 45. That's 135. Okay. So 9 times 15 was 135 tens. So we subtract. We still have 4 tens that didn't fit into those 15 equal groups. Now we're going to bring down the 6 ones. So now we have 46 ones. If we had 15 equal groups, we could put 3 into each group. So far we put 393 into each group. 3 times 15 is 45. We have a remainder of 1. Okay? So 393 is the whole number. So I can put that here for all of these. 393 is the whole number. Now the first one says to write it as a mixed number. So to do that, you're going to put we did this a lot, the remainder of 1 is going to become the numerator of our fraction, and the divisor of 15 is going to become our denominator. So it's 393 and 1/15 written as a mixed number. 393 and 1/15 written as a mixed number? Yes. Okay, so basically what we did was we take this last remaining 1, so I'm just going to draw a picture of 1, and if we split that into 15 equal groups, say 1, 2, 3, 4, 5, and then we'll make 3 groups this way. That would mean 1/15 would go into each group, right? This one could go into this group. This 15th would go into that group. And all 15 would be used, right? Those 3 went there. These 3 would go here. These 3 would go here. These 3 would go here. And these 3 would go here. And then we used up this remainder. Basically, we took it, and that's a really, really accurate answer. If we took that last whole and split it up into 15 equal groups, we could put 1/15 into each group. So as a mixed number, it's 393 and 1/15 could go into each group. Okay? You guys are pretty good with that. Give yourself some snaps. Now let's look at as a remainder. That's even easier. 393, we put an R, and the remainder was 1. So bingo, piece of cake. We did the mixed number easily. We did the remainder even easier. 393, remainder 1. And now's the hard part. We're going to write it as a decimal. And of course, I made a little bit of, kind of got in my way here with as a decimal. So let's see what we can do here. I'm going to just work around this drawing. Sorry, I got excited. I drew it right in the way. Okay, so what we're going to do here to write this as a decimal is we're going to continue. We're going to put a decimal point here after the ones place. Just like we're going to put a decimal point here. And right there. Okay, I'm going to scratch that out for now. Sorry about that. I did this last week too. Okay, so we're going to fill this in with 0 tenths. And we could even put 0 hundredths. We could keep putting 0 because there's none of them, right? So if we need to find a decimal, we can put a 0 here and we can just continue with dividing. So we have that 1 that's left over. So what we're going to do is we're going to mix that in with bring down this 0 tenths. So now 1 whole is the same as 10 tenths, right? So now we're going to say if we had 10 tenths, could we split that up into 15 groups? And the answer is we can't put any of those tenths, so it would be a 0 there in the tenths place. Sorry that was scribbled out, but that's a 0 there. Because if we have 15 equal groups, we only have 10 tenths. We can't put 1/10 into each group because then 5 of the groups wouldn't have the same amount. So that's a 0. Okay, so we're just going to multiply. 0 times 15 is 0. When we subtract, we're still going to have 10. And now we can bring down this hundredths. So now we have 100 hundredths, right? See how, again, we took that 1 whole. We tried to turn it into tenths. It was 10 tenths. Now we're down to hundredths. Notice how 100 hundredths equals a whole. So we still just had that 1 remainder left, right? That 1 whole that was left. Now we're just going to cut it up into hundredths so we can write it as a decimal. Okay? So now 15 goes into 100 hundredths how many times? So how many hundredths? If we have 100 hundredths, how many can we put into 15 groups? 15, 30, 60, 90. So it's going to be 6 times. So we could put 6 hundredths into each of those groups. So 6 times 15 is 90. We subtract. We still have 10 hundredths left. So we could keep going. We could put another 0 and go to the thousandths place. Bring down that 0. And again, we have 100. Now we have 100 thousandths left. And again, it's going to be a repeating 6 here. So 6 can go into 100. 6 times 15 is again 90. And we subtract, we have 10 again. So we're going to continue subtracting and having 10. So that's going to be our final answer. All right. So 393.06 would be the best answer as a decimal. Because it would continue with 6s. Right, you could continue with 6s here, but since it's a repeating decimal, we can just kind of put it like that, 393.06, and that 6 would continue repeating. That was tricky. Give yourself some snaps. Nice work. Okay, we'll let your teacher know if you have a little bit of trouble with this. They can give you some examples to practice. I keep running out of room because I get so excited about the mixed number piece. All right, but that's it. Pretty good. Let's go to number 2. Which of the following shapes appears to be a rhombus? So we've been talking a lot about polygons, so which one of these is a rhombus? And here's the definition of a rhombus. A rhombus is a polygon with 4 equal sides, 2 acute angles, and 2 obtuse angles. So the difference between a square and a rhombus, they're almost the same thing, except a square would have 4 right angles, right? A square would have 4 perfectly right angles in the shape of like an L. Like a right angle would be exactly like the shape of an L. Okay, so the only difference between a square and a rhombus is that these angles are different. So just like a square, all 4 sides are the same. Those are all the same length. The only difference is, see how these 2 angles here are acute? Those are the same number of degrees, but they're both acute. And these 2 angles here are obtuse. They're more than 90 degrees. So the acute are less than 90 degrees, and these obtuse angles are more than 90 degrees. So that's the only difference between a rhombus and a square. So just like a square, they have 4 equal sides, but the only difference is the angles, where a square has 4 right angles, and a rhombus, since it's like a little bit squeezed in, it's almost like a square that is just like angled a little bit, and then you end up with 2 acute angles and 2 obtuse angles. All right, so which one of these is a rhombus? It's got to have 4 equal sides, so these do not have 4 equal sides. That's trapezoid. It has at least 1 pair of parallel sides, though, so that is a trapezoid, but it's not a rhombus. This is a rectangle, or a trapezoid, because there's at least 1 pair of parallel sides. There happens to be, this is 1 pair, and this one would be 2 pairs of parallel sides. So that's a rectangle or a trapezoid, but it is not a rhombus. And this one is close, except notice how these pairs are shorter than these 2 here, right? These sides are longer, and for a rhombus, they have to all be the same size, like a square. So A is a rhombus. All 4 sides are the same size. It has 2 acute angles and 2 obtuse angles. So A is the correct answer for number 2, the rhombus. All right, give yourself some snaps if you got that. Nice work. And last problem, let's move over to the back. It says compute 4 2/3 plus 3 9/12. So let's add them. 4 2/3 plus 3 9/12. Okay, so the problem here is we do not have the same denominator, so we cannot add these yet. I'm going to circle that to make sure I don't subtract by accident. We need to turn the smaller one up, make it bigger, because we can multiply to get from 3 to 12, because these need to both be the same denominator in order to add these fractions. So 3 times what gets us to 12? It's 3 times 4. So now we have to multiply the numerator times 4 as well. That way we did 2/3 times 4/4. And since we multiplied 4/4 is really equivalent to 1, we just multiplied 2/3 times 1, and it doesn't really change the value. It just gives us this denominator of 12 so that we can then go and add these fractions. So 3 times 4 was 12, so 2 times 4 is 8. So 2/3 and 8/12 are exactly the same value. So now we have 4 8/12 plus 3 9/12. So 4 plus 3 is 7, and I always put a little addition sign here because we're going to have to add the whole numbers plus the fractions that we end up with. 12ths plus 12ths are 12ths, then we just add 9 plus 8 are 17/12. So the trouble with this is that this is greater than 1. This is a fraction that's greater than 1, so it's called an improper fraction. So we're still going to have to add 7 to whatever mixed number we turn this into. So 17/12 is division. It's 17 divided by 12. If we had 17 of something and we were dividing it into 12 equal groups, we could put 1 into each group. And then there's a remainder of 5, which will become our numerator. And the number of groups, or the divisor, becomes our denominator. So 1 5/12. So 17/12 is 1 5/12. All right, if I drew a picture of 12ths, I'm going to draw 2 holes here. Okay, if they were 12ths, that would mean that there are let's see, 1, 2, 3, 4, 5, 6, and then 12. And then if we made 12 more, 1, 2, 3, 4, 5, 6, and then 12. Yep. Okay, so if we had 12 twelfths would be this whole thing, one whole. And if we had 17 twelfths, then we would need 13, 14, 15, 16, 17 twelfths. So that's 5 more twelfths out of this whole. So we have one whole, which is 12 twelfths. And if we have 17 altogether, we have one whole and then 5 twelfths. Just like we got when we divided, 1 and 5 twelfths. So now we're going to do 7 plus 1 and 5 twelfths. When we add those together, 7 plus 1 is 8, and then 5 twelfths. We can't simplify that. We can't divide 5 and 12 by the same number to make them any simpler. So our final answer is 8 and 5 twelfths. And that is the sum of 4 and 2/3 plus 3 and 9 twelfths is 8 and 5 twelfths. Give yourselves some snaps. Nice work. And that's it. Hope everybody has a great day. This one was pretty tricky, so ask your teacher for a little bit of help or some more examples with these when you write it as a decimal, because I keep running out of space. All right, and that's it. I hope everybody has a great day. See you later.